Okay. All right. Hi, my name's Micki. Do you want to introduce yourself?
Hi, I'm Bailey.
And I'm going to read the book, What's Your Angle, Pythagoras. So you've heard about Pythagoras, right? What do you already know about Pythagorean Theorem or Pythagoras?
Well, a squared plus b squared equals c squared. And the most I know about him is that he was a mathematician in Greece.
Yes. Okay, very good. And what do you use his theorem for? I heard you say a squared plus b squared equals c squared, but what do we use it when we're dealing with what kind of things? I might not have heard that part.
Isn't that one graphing?
Yeah, it will. There is some elements of graphing, maybe if you've taken trigonometry. And so this is one of the most famous theorems. And let's hear this little story. So this one is it's a math adventure written by Julie Ellis and illustrated by Phyllis Horning. Long ago in ancient Greece, oh, you were right, ancient Greece. There lived a curious boy named Pythagoras. Pythagoras couldn't help poking his nose into places. Sometimes his curiosity got him in trouble, but sometimes it paid off. Does your curiosity ever get you in trouble?
Occasionally.
Occasionally, okay. One day, Pythagoras sat in the shade of an old olive tree. He could see the harbor and the sparkling blue sea around the island where he lived. Nearby, two workmen were building a temple. They began to argue. This ladder is too short to reach the roof. Pepros grumbled. That's not possible, said Saltos. The wall is 12 feet, so I made the ladder 12 feet long. What do you think the issue is? He made the ladder 12 feet, but it's not reaching the top. What's going on?
Well, the ladder's gonna have to be at an angle, so it's gonna be a little too short.
Oh, it's going to be a little too short. Okay, Pepros roared. The ladder only reaches the roof when it's flat against the wall, just like you said. And then no one can climb it. This is as bad as the columns on the porch. Pythagoras poked his head from behind the tree. What's wrong with the columns? He asked. Pepros frowned. It's that pesky Pythagoras again. Stop bothering us. At this rate, we'll never finish the temple. Oh, look, there's a kitty.
No.
Do you have any cats?
Yeah, we have one cat.
Oh, what's its name?
Her name's Selena.
Selena. We have 3 cats. So we have Lily, Milo, and Luna. Okay, so here's the columns. I wonder if you can see anything wrong with the columns.
They're all very kind of tilted.
Yeah, they look a little crooked, huh? So they were just complaining about the columns. As the workmen argued, Pythagoras crept around to the other side of the building. 4 columns stood on crooked bases. Some columns leaned to the left and others tilted to the right. Those columns will never hold up a roof, Pythagoras said to himself. I wish there was something I could do to help. Still thinking about the problem, he ran home for dinner. And there's the lazy kitty laying down like kitties do. When he got home, his father was talking about his ship. I sailed to Crete with a shipload of tiles, but Lepus and Boundus, I think, I don't know, I'm bad at reading these names. Or maybe Lepus and Boundus. Oh, like leaps and bounds. Lepus, I get it. Got there before me. With his first new ship, they will take away all of my customers. Through a mouthful of bread and olives, Pythagoras asked, Father, you always sail to Rhodes first and then Crete. Why don't you just sail through from here to Crete? That would be a lot faster. It's too dangerous, his father replied. It would not be safe to sail straight from here to Crete unless I knew the exact distance. Out at sea, I could miss Crete and end up anywhere. I'm leaving for Europe or Egypt tomorrow. I want I want you to come with me, son. One day you will command my merchant ships and you will have much to learn. And there's the bread and olives. Wonder what happened to the kitty.
Hmm.
Can you see the book okay?
Yeah.
Actually, it's lighting up with the universe, isn't it?
Yeah.
That's kind of cool. I actually love that. It looks really awesome. At dawn the next morning, Pythagoras and his father set sail. As they sailed along the coast, Pythagoras said, I can't wait to see Alexandria. I hear they have great buildings there. I might want to be a builder someday. But son, you are going to be a merchant, his father said. The goal of a merchant, or the life of a merchant, is exciting. You can set sail to faraway places. He put an arm around Pythagoras' shoulder. You just have to look at it from the right angle. Oh, you see what they did there?
Yeah.
Soon they were sailing into the port of Alexandria, the capital of Egypt. Pythagoras marveled at the great lighthouse that stood proudly beyond against the sky. Saltos and Pepperos, oh, like salt and pepper, Saltos and Pepperos should see this, he exclaimed. Oh, it is gorgeous. Can you see? It's just the universe, actually.
Yeah.
That's so cool. The green screen. Okay, I guess it's a greenish blue, huh?
Mhm.
At the dock, a man greeted them. I am the builder. Oh no, that was a hard one to say. Nefer Hepper Hearsekeeper. What? I wonder if you can see that word. Maybe not because of the green screen. All right. Well, that's his name. Oh, luckily people call him Neff for short. Okay, thankfully I don't have to say that whole name.
Yeah.
I'm here for the tiles. Pythagoras was excited to meet a real builder. Have you built anything around here? He asked. Neff nodded. As a matter of fact, I helped to build a lighthouse. How did you get the base so straight? Pythagoras asked, thinking of the crooked columns back at home. You must be a master builder.
Mm.
Neff smiled and stuck out his chest. The secret is the special rope that's been used by my family for ages. You use a knotted rope to cut stone? Pythagoras asked. Neff laughed. Dear boy, this rope does not cut stone. I use the rope to make a special triangle. I call it the right triangle because it helps me make nice square corners that's exactly the right angle for cutting stone. Do you know what a right triangle is?
Yeah.
Oh no, the video froze.
That one.
Yes.
Oh.
Go ahead, sorry.
No, that was it's exactly half of a square. So
Okay, yes, and it has what kind of angle in it?
90 degrees.
90-degree angle. So whenever I say to my students, oh, are you feeling cold? And they say yes, I said, well, you should go stand in the corner. Why is that?
Because it's 90 degrees.
It's 90 degrees in the corner. That's a right angle. That's right. That's right. Okay, so we have a right triangle here. And I know it's a right triangle because we have 90-degree angle in one of the corners, one of the angles, not both, right? Or not all three. There's three angles, only one of them is 90 degrees. So Neff let Pythagoras hold the rope. Pythagoras made some triangles, but none of them had the right angle. How long do you make each side? He asked. Oh, I've shown you too much already, chuckled Neff as he took back his rope. Why don't you run along now? He's not going to tell him. As his father and Neff talked, Pythagoras found an old piece of rope and tied knots in it. He pulled the rope into different triangles. Finally, he made a triangle that seemed right. It had a length of 3 on one side, a length of 4 on the other side, and 5 on the longest side. I've got it, he said to himself. There's his 3, 4, 5. We call that a 3, 4, 5 or a Pythagorean triple, right? Anytime you have a right triangle, that works out with all the sides to be rational numbers, actually even, yeah, rational numbers as opposed to irrational numbers, then we call that a Pythagorean triple. Do you know of any other numbers that make it work out perfectly, a Pythagorean triple?
Off the top of my head, I do not.
Okay, well, if you know that this is 3 and this is 4 and this is 5, what would you get if you doubled each side?
6, 8, and 10.
6, 8, 10. So 6, 8, 10 would also work. What would happen if you tripled each side?
Okay. 9, 12, 15.
Yes. So if you keep taking the 3, 4, 5 and you multiply it, you could even half it. You know, you could divide, you could make it smaller. But basically what you're doing is you're using proportions to make the triangle bigger or the triangle smaller. And we multiply or divide by the same number. And then it's also called similar triangles, right? So they're not exactly the same size, but they're similar in their shape and they're similar in their angles. And there will always be that right angle. Another Pythagorean triple that I love is a 5, 12, 13. So if you look up Pythagorean triples online, you would probably find a lot more. That's the only other one I have memorized right now. But again, if you take the 5, 12, and 13, then that will also work. And we'll find out more about this. So just then, Pythagoras' father said, "Carry this crate of tiles, son. Neph and I will carry the rest." "I would carry them," Neff sighed, "but I have hurt my thumb, so I can't. You'll have to make 2 trips." When they got to the house Neff was building, he said, "While you get the rest of the tiles, I'll get the money I owe you." Grumbling, Pythagoras' father headed back to the ship. He's probably mad. He has to take 2 trips, right?
Yeah.
Neff patted Pythagoras on the head. "Be a good boy and watch these tiles for me," he said. So he said as he disappeared into the house, "And don't touch anything." Pythagoras looked around the sunny orchard. In the middle stood a statue base made of stone. He took some tiles out of the crate just to see how they would look around the base. "I can put them back quickly," he thought. He made a row of 3 tiles along one side of the statue base. And then he added 2 more rows of red tiles, making a square. So here is his red tiles. And he has 1, 2, 3, 4, 5, 6, 7, 8, 9. We call this a perfect square, right? Because it's 3 times 3. How many tiles do you think there are here?
4 by 4.
Yeah, and that would make how many?
16.
And then how many tiles do you think there are here?
25.
25, because how'd you get that?
5 by 5.
5 by 5. Right, so we call this 3 squared, 4 squared, 5 squared. So the triangle was 3, 4, 5. And if we square, now what do you notice about, you had mentioned before, a squared plus b squared equals c squared. So what do you notice about these squares?
Well, they're all the same size, and so they're all the same measurement, which would mean that one would be equal to, yeah.
Yeah, that's okay. So if you notice, they put some red and green, or sorry, some red and blue tiles mixed here together. How many red tiles do you see?
9.
Ah, and how many blue tiles do you think there are there?
16.
16, because a squared, which is 9, plus b squared, which is 16, is equal to 25. 9 plus 16 is 25, which is 5 squared. And it looks really cool, huh? Because it's all lit up with the universe.
Yeah.
Some of these crates have blue tiles, Pythagoras said. Soon red and blue tiles were scattered everywhere. Pythagoras made a square of blue tiles with a big square of red and blue tiles. He was admiring his work when he noticed, this statue base is a right triangle. Its sides are 3, 4, 5 tiles long. He counted the tiles. Strange, he thought. The 9 tiles of the red square plus the 16 tiles of the blue square equal the 25 tiles. There are exactly 25 tiles in the big red and blue square. Suddenly a voice demanded, "What do you think you're doing?" He's in trouble now. Neff rushed into the courtyard. Pythagoras' father was right behind him. "What's all this?" Neff snapped. "I'm sorry," Pythagoras said. "I was going to put the tiles back, but I found out something interesting." "I don't care what you found out," interrupted Neff. "Look at this mess." Pythagoras picked up the tiles, and his father said sternly, "And hurry, we have many with 3 tiles on each side had 9 tiles. The one with 4 on each side had 16, and the one with 5 on each side had 25 tiles. So in the square, the length of the side times itself is the number of tiles in the whole square. I call it squaring. How convenient. When I multiply a number by itself, 3 times 3 is 3 squared. I'll write it 3 to the second power. There's a little exponent. Very good. And you already predicted all of those, so you saw that combination. Pythagoras drew a new picture. 3 squared plus 4 squared equals 5 squared, he said to himself. I wonder if the squares on the side of the other right triangles add up the same way, he thought. Pythagoras practically flew off the ship when he got home. He could not wait to tell Saltos and Pepros about the special knotted rope and the secret of the right triangle. It's going to fix all their problems now, isn't he? When he got to the unfinished temple, Saltos and Pepros were not there. The ladder was on the ground where Pepros had thrown it. The ladder would be easy to climb if the bottom were 5 feet from the wall. Pepros said that the wall is 12 feet high. He drew a triangle in the dirt, 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. If we add that up, we get 169. What would we do to find that missing length of the triangle with that 169?
Would you square root 169?
Yes. Do you know what the square root of 169 is?
I do not.
What would be your guess? Just make a guess, do you think?
Oh dear.
Well, 144 was 12 squared, and 169 is just a little bit more than 12. So maybe the next number after 12.
13?
13, yeah, the next whole number, right? And it is. 169 is 13 squared. Interesting fun fact, 14 squared is 196, 15 squared is 225, 16 squared when we were doing the binary numbers is 256, 17 squared is 289. You see how that goes. Okay. 20 squared is 400. All right. I skipped 18 and 19 because I don't think I remember those. At home, Pythagoras got out a map. He looked at it closely. I wonder, he said to himself. That night, Pythagoras announced, oh, that one's going to be fun. Green screen, huh? Oh, it's not working. I think it works almost a little better with blue. That night, Pythagoras announced, I found out the distance from here to Crete. His father nearly choked on a fig. His mother asks, how can that be, son? Pythagoras answered, I discovered a pattern that works for any right triangle. I used it to figure out the distance. Now father can sail straight from here to Crete. His father stood up. Son, I cannot risk my ship because of some triangle. Doesn't believe him. Father, Pythagoras started to explain. At that moment, Saltos and Pepros came rushing in, puffing hard as they had been racing up the hill. Pepros turned to Pythagoras. You did something to our ladder. Has Pythagoras been bothering you again? Said his father, frowning. Salto shook his head. No, he made the ladder the perfect height. We will be able to finish the roof now. Pepros added, then all we'll have to do is fix the crooked base of the columns. Maybe I can help, Pythagoras offered. Use my rope to make right angles. If you use a right angle to make the base straight, the columns will stand straight. Saltos laughed. Great! Now we can finish the temple on time. You're welcome to stop by and help us anytime you like.
Mm.
And so he has the base there has all right angles. Just like you were saying, I think you were mentioning something about half of a rectangle before, right?
Mm-hmm.
Rectangle, you cut it in half, and you have two right angles. Pythagoras' father said, son, on a second thought, maybe you should tell me about the distance to Crete. Oh, now he's getting interested. Maybe it'll work after all. Pythagoras explained, our island, Samos, forms a right triangle with Rhodes and Crete. If I call the side of the triangle, the sides, A, B, and C, I can use my right triangle pattern, A squared plus B squared equals C squared, to figure out the distance from here to Crete. So here's the map, and can you see the right triangle that they're forming? What do we call the longest side of the right triangle? Do you remember that word?
Hypotenuse.
Hypotenuse. Sounds a little bit like hypothesis, but that's your theory of what's going to happen in science. So it's the hypotenuse is the longest side, and it's always across from the right angle.
Mm-hmm.
You can see how A squared plus B squared equals 34,225. Now, I had no idea that that's a perfect square, but maybe it is. You can do this to estimate though too. So actually it's maybe not a perfect square, because here's his work, and oh no, actually he gets, all right, well, let's read it. I'll just read it instead of trying to figure it out. To find C, the distance from here to Crete, so this distance here on the map, right, from here to Crete,
Mm-hmm.
I had to find the number multiplied by itself that equals 34,225. I already knew that 148 squared equals 21,904, so that's a perfect square. That's too small. And I tried 200, but 200 squared equals 4,000. That's too big. So I tried 180, and 180 squared equals 32,400. Well, that was close. And then I tried 185 times 185, and I got exactly 34,225. Isn't it nice when math just works out so nicely? The numbers are just perfect like that. So the distance from our island to Crete is 185 miles. So he's going to save all this space, right? Because he was going to go from here 111 miles and then go 148 miles. Instead, to go directly, he only has to go 185 miles. So that's quite a bit of distance saving, isn't it? We can do that math, I bet. Everyone was amazed. Pythagoras' father clapped him on the back. Good thinking, son. You'll make a fine merchant someday. Pythagoras' mother said gently, perhaps he can use his quick mind for other things. His father nodded. Son, with your clear thinking, you will be a general, a senator, a teacher, or anything you want. It's your choice. Pythagoras smiled. He hoped to do great things in his future. A few days later, Pythagoras saw his father's boat sailing into the harbor. His father ran to greet him. Pythagoras, you were right. I made it to Crete in record time. Oh, that's a whole math problem I bet we could figure out. His father said, hugging him. That will be in book 2, right? Pythagoras looked up at his father and said, you were right too. I just had to learn how to look at things from the right angle. And this has a little bit in little historical note here. Pythagoras was born in Greece on the island of Samos around 569 BCE. So that's like negative, right?
Yeah.
Before 0. The actual events, what is that actually? I can't remember. What does BCE stand for? Do you remember?
Before Common Era.
Oh, what does that mean, before Common Era? This is your history buff coming out now. Perfect.
Yeah. So
For Common Era.
there's always like before Christ and stuff like that, which is the more religious term for it.
Oh, that's why it was it used to be BC. Okay.
Yeah. So it's the same like time period. It's just when like Jesus was born. It's the cutoff for a lot of historical accuracy for the year, and so they just kind of changed it to make it less religious and more.
That makes sense. All right. They probably did that since I've been in school, because I don't know if I've seen BCE. So the actual events of his childhood are unknown. So this is probably a fictional story. He founded a school in southern Italy after traveling in Europe and the Middle East. He was a philosopher, musician, astronomer, but he's most remembered as a mathematician. His most famous discovery is what we now call the Pythagorean Theorem. And that's where A and B are the two legs of a right triangle, and C is the opposite side of the right angle, or the hypotenuse. And you already knew about that Pythagorean theorem.
Mm-hmm.
Yeah, but some other interesting thing about Pythagoras, I guess he was a vegetarian, and people wanted into his school. His school is kind of like more, I mean, this is something I've read. Who knows if this is true? That was a long time ago. But they said that he was a vegetarian and that people wanted into his school, and so he wasn't letting just anyone in, and so they actually chased him down, and then he wouldn't trample on the beans, and so then that's how he got captured. I don't know if that's true, but that's maybe just like a story, a little bit of folklore about him. Well, thanks so much for reading What's Your Angle, Pythagoras with me. That was really fun. Yay.
Yeah.
Cute. Yes. And now whenever you do the Pythagorean theorem, you'll remember it, and I'll just go hi so you can see the comment. Cool. Thanks so much, Bailey. I'm going to stop the recording now. Oops.